Hi, my name is Derek Wells. This is my Discrete Math in the IT field presentation for my class project. I chose the creation of the perfect password. Alright, so I decided to use the area of cryptography in the IT field. Now, cryptography is a method of storing and transmitting data in our particular form so that only those for whom it is intended can read and process it. A part of the area of cryptography is the establishment of a password in order for users to gain access to that data that is being transmitted. Usually passwords must meet a certain set of criteria to be considered valid. So I can relate this to discrete mathematics with the concept of set theories by equating certain criteria for the password into certain elements to prove my set. So, for example, password requirements for this certain password must contain at least one lowercase letter, one uppercase letter, has to contain one of these special characters. I chose the @ symbol, the pound symbol, and the exclamation point, and it also must be a minimum of 8 characters. So we put this in discrete math terms. A is equal to the set of all lowercase characters. B is equal to the set of all digits between 0 and 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We make C, D, and E equal to each one of the 3 symbols that I want to use. C being the @ symbol, D being the pound symbol, E being the exclamation point, and X being the submitted password that I'm trying to get through. So if we were to put these into the set theory equation, it looks something like this, where X, my submitted password, should be equal to at least one A, which is a lowercase letter, and, or union, at least one B, one digit 0 through 9, and then we, in parentheses, we pick one of the symbols, C, or D, or E, and then our last one is where characters in X, our submitted password, are greater than 8. So as long as there's more than 8 characters and all the other criteria are met, then X is going to be a valid password. So let's go ahead and put this in the other slide, and we'll go ahead and run through a couple things. So we take X and we set it to my name, Derek, D-E-R-E-K, in capital letters, with the exclamation point and 1, 2, 3. So we're looking through, and we notice that it becomes invalid because it's not in A. So there is no lowercase letter in this password, so it's not going to be valid, even though B, C, or D, or E, so we were able to do E, was in there, and the characters were greater than 8. There was no lowercase letter, so this would be an invalid password. So we can look at the next one, okay? My name, Derek, we changed it up and did lowercase, so it proved A. 1, 2, 3, 4, so we had at least one of B, which is a digit. However, we are missing the and, C, or D, or E, because there is no symbol. Yes, the total characters in the password are greater than 8, however, that would also be invalid. Okay, so let's check this one out. This is my first name and last name, Derek Wells, lowercase. We decided to put in the symbol, I believe it was D, the pound symbol. So it met all the criteria greater than 8, except it didn't have a number this time. So because B was not met, it's invalid. So we finally come to one that, I think it might work. So we go through, and it's Derek lowercase, the @ symbol, 1, 2, 3 numbers. So we go through this whole thing where X, my password, is equal to at least one A. So is there one lowercase letter in there? Yes. And at least one B. Is there a digit in there? Yes, there's actually 3. It had at least one, so that validates criterion B. And having one of the symbols of C or D or E, which, as we can remember, is the @ symbol, the pound symbol, and the exclamation point. Well, we have the @ symbol in here, so that fulfills that criteria. And then also where characters in my password are greater than 8. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. So guess what? Valid. My password's accepted. So there's a case of discrete mathematics being used in the IT field. Thank you so much for listening. Have a great rest of your evening.